we go. We got two indefinite integrals to find, right? Two indefinite integrals. Now they're both quotients, yes? Both quotients. So with enough practice, we don't have to physically rewrite things to test to see what rule we're going to use. I know in this one, the two's out front already. I'm not worried about it. If I were to rewrite the bottom and the top, it would be all to the negative 1/2. And that's what I would call my inside function. Okay. So mentally, I'm going to pick up on these nuances a little bit faster. And I'm going to say, okay, what's the derivative of that? It's negative 12x cubed. The other factor in the top is not an x cubed though, right? It's an x. So bringing that to the top and saying it's to the negative 1/2 power, it's not going to be helpful here. So what else can we do? What are some of our strategies? Split up numerators, can't do that. F it, right? No, we can't factor it. Long division doesn't work because the degree of the top is 1 and the effective degree of the bottom is 1/2. Well, it would be 4/2, which is 2. Yeah, so that doesn't work. What do we use when we're at the end of our rope, but we're still above the knot? What? Well, you can't just take the square root of both of those. No, inverse trig. Inverse trig is our last resort. Now, because it has a radical, it's not going to be arctangent. So the question is it arcsecant or arcsine? Well, it's number minus function. So that one has to be arcsine. So A would be A squared, and this would be U squared. So A would be, yeah. Yes. Yes. Yeah, you certainly can. And I'll show you why. Here's why. A is going to be the square root of 8, and U is going to be the square root of 3x squared. Yes, yes? Well, it would be harder because remember, we always have to check by taking the derivative. And if, yeah, so you'd want to simplify it. Yeah. I mean, you could identify it as the square root of 3x to the 4th. Yeah, and then breaking it up so you could take the derivative. Yeah. So, and here's why we can have something in the top. Whatever we're calling U is now our inside function. We have to always check what is the derivative of U. It would be 2 square root of 3 x to the first. So that's where the x to the first came from. Yeah. So we pick up the important variable part. We're just off by a 2 square root of 3. Right? And why did I say we're off by 2 square root of 3? Because remember, my 2 from here, he's already in my final answer waiting. And or you can absorb him if you do it that way. Okay. But now I'm off by a 2 square root of 3. So I have a correction of 1 over 2 square root of 3. And notice your 2's are going to divide out anyway. So if you're of the mindset to saying, oh, no, we get the 2x, I'm just off by a square root of 3. Now the 2 gets packaged back up. But that's not how I've been training you. So if you understand that, that's fine. So we always have to check. And that's why if your degree in the bottom under the radical is larger than x squared, like x to the 4th, that's how you get a variable in the top. Okay. All right. So we got the correction. We got the rider. Now the question is, does arcsine have a 1 over a in front? No, it doesn't. It's the only one that doesn't. So we go straight to arcsine of u, which is square root of 3x squared, over a, which is the square root of 8, and then plus c. Okay. And of course, you could simplify after that. Your 2's divide out, so you get 1 over the square root of 3. It could be inverse sine instead of arcsine. You can write the ratio here as a coefficient. Square root of 3 over the square root of 8 simplifies to 2 square root of 2 times x squared plus c. And then if we rationalize it, it's starting to look a little ugly. But you get the idea. You can multiply by square root of 2 or square root of 2, blah, blah, blah. But there it is. It is an inverse trig. Okay. So be aware of that. Yeah. If it's not just something minus an x squared, but if it's an even power, x to the 4th, x to the 6th, then we can have x's in the top. Okay. All right. Now, when you compare that to letter B, again, if I walked up to this for the first time, I would notice the quotient of 2 variable functions. I would mentally bring the radical to the top and say that would be the inside function. And I mentally check what's the derivative of that. It's negative 12x cubed. We have the cubed in the top. Yes. So now this is going to be a simple power rule. And so I don't mess up the power rule by trying it in my head. I will rewrite it now. So now the 2 I'm bringing out front. I got an x cubed. It's 8 minus 3x to the 4th, all to the negative 1/2 power. And there it is. Now rewriting it makes sense to me. And again, you could check the derivative is negative 12x cubed. We get the critical variable part. So the writer is in our answer as a 2. We're off by a negative 12, so we have a correction of negative 112. And now you move on to the next part. What is the rule of integration? Well, it's always going to involve the outside function, which is blob to the negative 1/2. So we leave a little space. That's blob to the add 1 to get 1/2. And then dividing by 1/2 is the same as multiplying by 2. So that's the rule coefficient. And then plus c. And of course, the blob stays the same. 8 minus 3x to the 4th. And now if you simplified that, you're going to get a negative 4/12, which is a negative 1/3. 1/2 is the radical on the top. And then plus c. Okay. What? You forgot plus c and you turned to the left.
I turned to left. I went to Landon.
He can't handle any left turn.
Okay.
No. No. If you want to talk to Landon, you make 3 right turns, but no left turns. Okay.
Wait.
That's
Landon literally talked about.
you broke his brain by
I
saying
forgot.
you
But no,
were
it's like
right.
you still get.
No.
Every time Landon
Okay. Let's go ahead and come back up here. Example 4. All right. Now that we're all good and warm, right? Whenever the talking picks up, I know we're all good and warm, right? Vocally. For each of the following, we want to find the general solution to y equals f of x. General solution means what? Plus c, Hank. If it were a particular solution, we would do the plus c, and then we would find the value of c using the point that they gave us, the initial condition, by algebraic manipulating it. Okay, so remember that separable differential equations that are not functions of your independent variable x, if there's any dependent variable on the other side, which remember, the great question was yesterday, how do we know? Dianar asked it, right? The dependent variable is always the top, right? This is your dependent variable, and then the bottom is always your independent variable. That's why we say the derivative of y with respect to x. X is kind of our control variable, all right? But if you have anything on the other side other than x or constants, you have to separate it by either multiplication or division, okay? Let's just say that. Separation, and remember there's a rat in separate, must come from the heart. Oh, no. Separation must come from either multiplication or division, not from addition and subtraction. No. If you want to add that, not from addition or subtraction. Okay, no. Now, the equations that you're expected to do, if you are expected to find the general solution, there will be a way to algebraically manipulate it so that you can separate the variables. But typically, when you're done with all your calculus learning, including multivariable calculus, the capstone calculus course is differential equations. And what you do is you look at equations that are not separable. There's all kinds of ways you can still solve them by doing transformations on them, Laplace transformations. It's pretty fun. It's pretty cool. So hopefully, if you're majoring in math or going into engineering, you'll take that course someday. Okay, it's pretty fun when you have a really strong foundation. Differential equations, the capstone course is a lot of fun. Okay, so having said that, let's look at this. We have derivative of y with respect to x equals e to the x minus y. Right? I can't just say, ooh, the antiderivative of dy dx is y, and the antiderivative of e to the blob is e to the blob. Right? That doesn't work, does it? No. The reason that doesn't work is because I have a dependent variable on the right-hand side. So now I's got to separate them, okay? I happen to also have an x, but if you had just a y or a y and an x, you'd have to separate it. And it has to come from multiplication or division. So the first step you can always do, kind of like priming the pump, you can multiply both sides by dx. dy equals e to the x minus y times dx. And then you ask yourself, did that do the trick? No, that did not do the trick. I still got, and you're like, crap, how in the heck, what can I do? Natural log both sides? Well, let's try it. I get the natural log of dy equals the natural log of e to the x minus y dx. Oh. That's not a bad idea. I know why you're thinking natural log, because it brings exponents out front, yes? But the problem is right now my X and Y that I have to separate are being whatted? Subtracted. And I can't separate X's and Y's with simple arithmetic, addition and subtraction. I have to do it by way of multiplication or division. Yes, Hank.
Oh, wait. What if you have e to the x minus e to the y?
There you go. We saw that trick the other day when we had the e to the x plus c, and we brought the c out front. That's e to the x times e to the negative y. Boom. Okay. That's the magical step. That's the magical step. That turns it into multiplication. All right. Now, how can I get rid of e to the negative y? I can divide both sides by e to the negative y, and we could show that. It's kind of elementary to show that, but as long as you show it on both sides, right, it's still legit. Even in your bench work that came up this morning and landed in session, whenever you have an equal sign, even on your bench work, when it's not intended for eyes, if there's an equal sign, it has to be equal. In other words, if you're going to do it if you're going to do it like this, you're like, oh, I know it divides out over there, so it's going to be gone, so I'm going to put it over here. Even if there's only, you're going to lose a point right here, because you can't mess with equality, right? If you're calling something equal, it's got to be equal. Now, ooh, that's not how I want to do that. There you go. Those divide out. So I'm left with e to the x dx. And over here, that looks ugly, but can I bring the e to the top like that? And what happens with the exponent? It becomes positive. Oh, there you go. Turn that frown into a smile. Concave down is now positive, positive, positive. Did that separate the variables? Y's and dy's on one side, x's, dx's on the other? Yes, it did. Kaboom, separated the variables. I was looking over right now for Ryan and for him to dance like a success dance, but he's not here. Oh, no. Okay, I'm sorry. Yeah, yeah. All right. I'm sorry. Yeah, there you go. Now we sneak us. I'm going to look right because I feel like I don't get over to that side of the classroom enough. Okay. Now we're going to sneak that slender, sneaky, snaky integral symbol in there. This is like the worst seat in the house, but some people like to sit here, you know, and then I look back at them like 5 minutes later and they're over here, you know, and then 5 minutes later, I look at them and they're in Miss Richter's room, right? People just want to like get as far away from the math as possible. So anyway, and then the view here, right? All right, so there you go. We separated the variables. Now we sneak that slender integral in, and now it's time to integrate, baby. What is the antiderivative of e to the y with respect to y? E to the y. Do we need a plus c on the dependent variable side? No. And on the right, I'm my own grandpa and grandson, right? Same thing. E to the x plus c. Yeah, it's got to appear immediately. All right. Now I need to solve for y. How do I un-e something? There's the natural log. So now if I natural log both sides, remember the plus c is now contained inside the argument. This is why you can't just add it at the end like garnish. It's got to be there the whole time. So I get y equals the natural log of e to the x plus c. So if this were like a multiple choice question, of course, that would be an answer choice. But here's another answer choice, right? Y equals the natural log of e to the x plus c. And that would actually simplify to what? Just x plus c. Yeah. So this is wrong. You can't just add a c as an afterthought. And another answer choice might be 7. I don't know. Just, yeah. 42, maybe. Okay. All right. Everyone good with that? The magical step was turning the subtraction into multiplication. All right, let's look at letter B. Cowabunga, dude. Let's see. I got a minus x on that side. Should I multiply both sides by dx? Okay. So I get dy over dx minus x times dx equals dx times xy squared. You can multiply by dx on the left-hand side. You can treat it like a separate factor. We typically like them on the right-hand side. Now, let's see what happens. If I distribute here, if I distribute there, the dx's divide out in the first term, and then I get minus x dx, and then that equals over here xy squared dx. Okay, that did the trick, right? My y's and dy's are on one side and x's and dx's are on the other. Ah, very good. This is alphabet soup, right? Let's get this dude to the other side. Red Rover, let x dx come over. And now it's positive. So x dx plus x y squared dx. And that did it, right? Y's and dy's are and dx's. And now is that? Ruh-roh. What are you doing on this side, y squared? Go be with your own people. But I like y'all.
He's not like the other Y's.
There you go. Yeah. We should not have distributed the dx up there. That was kind of a bad move. But, you know, you could salvage this with a little sisu. We're going to have to factor the dx back out. So x plus xy squared dx. Uh-oh. Ah, I can factor out an x as well. Now I'm going to factor the x out on the front, and that leaves 1 plus y squared dx. Now it's looking good because now I've isolated the y in its own factor. Constants are benign. Constants can be associated on either side. So now what's the last step to isolate the x's and the y's? Yeah, divide both sides by 1 plus y squared. And it's gone, and you're left with x dx on this side. And I'm going to rewrite this as 1 over 1 plus y squared dy. Did that do the trick? Yes, that's sisu right there. Now, what would have been a better first move would have been to separate or isolate the dy dx first by bringing the x across, and then factoring out the x times 1 plus y squared, and then doing the double switcheroony if you want, right? So as long as you're doing legitimate algebra, it'll still work out. Sometimes though, you might want to abandon ship and retreat back to a previous line and try going down a different fork in the road, right? Just because you turn down one alley and you know that it gets you to your destination, if you see like some thugs down there and they're beating people up and taking their math as you walk by, you don't have to be brave. You can okay, guys, I'm backing up, and you just go down a different alley. Okay. All right. So now that we've separated the variables, now it's time to do the calculus part, right? Because that was just algebra. Sneak that slinky integral symbol in there. Now on the left-hand side, if I bring the 1 plus y squared to the top to the negative first, is it a natural log rule of integration? This would be your inside function. What would be the derivative of that with respect to y? It's 2y to the first. Do I have a y factor in the top? No. Ah, very good. So this is arctangent. Straight up arctangent. Straight up. Now, if you want, you could still say A is 1 and U is y. But it's just arctangent, okay? Arctangent of y. Do we need a plus c over there? No. So that equals 1/2 x squared plus c. All right. And now we're almost there. This is not the general solution, not until we solve for y. How do we unarctangent something? Tangent it, right? So tan of arctangent is just y, and I get tangent of 1/2 x squared. And is the c inside the angle or outside? Inside. Boom. There's your general solution. Okay. Yeah. Okay. Again, when you get a question like this on a free response, this is typically worth 5 or 6 points out of 9. Okay. It's very important. If you end up getting the right answer, but you don't show the separation right here, there's always a little rule that says, no soup for you. 0 points out of 9. 0 points out of, you're disqualified, okay? All right, let's move along then, okay? Example 5, this has multiple pieces then, like a free response. For the differential equation, y dy dx minus x equals 0, part A, find the general solution equation. Okay, general solution. Got to separate my x's from my y's. What's our first algebraic step then? What should I do? Yeah, let's plus x. So I'm going to get y dy dx equals x. Yeah, good. Now what? Should I divide both sides by x? Multiply both sides by dx. Yeah, y is already over there. So y dy equals x dx. Did that do it? That did it. So that's going to get a check for separating the variables. Now we could do a little calculus. Sneak that fella in there. On the same line, that's fine. Okay, on the same line. Now go ahead and do that one yourself. Pick up from there on your own. I've got to do a water replacement here. If you're listening at home, I'm putting a new water bottle in the ice maker while the students do the work. And there it is. It's seated. And now we can get back to math. That donation bucket on the water is getting pretty heavy. I appreciate y'all chipping in. I can fill a whole 5-gallon thing for $1. It's pretty good. What? Some lemonade packets?
I might set up like a smaller little cup.
A little stand over there and you sit behind it during class and sell lemonade?
Maybe.
Is that what y'all got for the antiderivative? That would get 1 check for both antiderivatives and 1 check for the plus C, probably, because the 2 antiderivatives are pretty much the exact same. All right, if I multiply everything through by 2, I get y squared equals x squared plus, do I have to put 2c? No, ShamWow C. ShamWow C right there. I'm still on the path to solving for the general solution so I can absorb constants. And now when I take the square root, I can't forget to remember to do what? Plus or minus, yeah. Now, because this is not the natural log variety, there's no way to get the C out front to absorb the plus or minus. It's only for the exponential. Yeah. No, because we're taking the square root of both sides. And is it true that the square root of 9 plus 16? That's the square root of 25, isn't it? Which is 5. If you took the square root of each of them separately, that would be 3 plus 4, which is what? 7. Yeah. Yeah. So you can't do that. You can't do that. The square root of a squared plus b squared is not a plus b. It's because they're terms. Can't do that. I mean, you could treat C as a constant and it can absorb something, but it can't absorb that, right? So I think if we had like C here, let's say on the step before, it happened to be that. Now when I take the square root of CX squared plus or minus, now because they're multiplied, I could say, hey, the square root of an unknown constant, that's the square root of an unknown constant. So I have the property that says I can do that. Uh-oh. Okay. I'm heading. All right. Yeah. Y'all pause. I'll pause the recording. Uh-oh. A fight.